Ethan? Let's see. I'm not feeling so good today, so I'm not going to sound real chipper. So we got a few more notes in section 2-3. So it's just some extra theorems and working on some proofs. So here's our given. We've got a diagram. Angle 1 and 2 are right angles. And we've got to prove that angle 1 is congruent to angle 2. So we got the given. Now, if they're right angles, by definition, we know what their measures are. So I know that the measure of angle 1 is 90 degrees, and the measure of angle 2 is 90 degrees, because that is literally the definition of a right angle. Since those both equal 90 degrees, they equal each other. So I just substituted. And if their measures are the same, the angles are congruent, because that's the definition of congruent angles. And I know you're probably sitting here going, well, that was obvious. Well, yeah, it is obvious, but learning how to justify every single thing you say, not so obvious. And also a really important thing to know how to do. I think you would agree that we would be better off in life if everybody had to know the reason why they believe things. There you go. Okay. I need some more coffee. My head hurts. But I can't go missing school. I missed Monday because I was out of town, but I can't go missing another day. All right, so this is super important. And we learned this last year in 8th grade accelerated math. Vertical angles are congruent. And that is a theorem. And we are going to prove why it's true. Now, did you notice, this is a theorem that all right angles are congruent. So from this point forward, we have proven that theorem. Now you can use that as a reason in a proof. So you could go straight to, if they told you these two are right angles, you could go straight to the fact that they're congruent, and you could give your reason is the all right angles are congruent reason. Okay, so angles 1 and 2 are vertical angles, so that's our given. And we should probably talk about the particular definition of vertical angles. So we'll put this over here. So vertical angles, and I know you know what they are two angles such that the sides of one angle are opposite rays of the sides of the other. So that's a better definition than what we got last year. So last year we would just say, oh, two lines cross, the angles across from each other. That's not really a definition. This is a definition. So if you're looking at angle 1 and 2, here's the sides of this. That's an opposite ray of this. That's an opposite ray of that. So that's a real definition. Okay, so we could go here and say that the measure of angle 1 plus the measure of angle 3, because we're looking at these two together, we know that's 180 degrees, because this is the linear pair postulate. And at the same time, because we're trying to get things down to angles 1 and 2. So that statement had angle 1 in it. Let's figure out something that we could say that has angle 2 in it. I could also say the measure of angle 2 added to the measure of angle 3 is 180 degrees for the same reason. So I can put it in the same statement. And then since they both equal 180, these two quantities equal each other. Because that's just a substitution. And then I could subtract the measure of angle 3 off each side. And then I'd have the measure of angle 1 equals the measure of angle 2, because that's the subtraction property. And here's another one of those things. Hang on, I just looked at my notes from years past, and I wrote this one in there. I still don't think it has to be there. Like, this is the reflexive property. I think it has to be there when we talk congruency. That measure of angle 3 is equal to the measure of angle 3. These are numbers. It's obviously the same thing because they're the same thing. And I used to drive, I think I told you this yesterday. I used to drive the other teachers crazy because I'd be like, you don't have to put that. Like, are we going to write down that 7 equals 7 every time we just subtract 7 from each side? But to make the numbers line up, I guess I'll put it in there. So then I could say that the measure of angle 1 is equal to the measure of angle 2, because that's the subtraction property of equality. And again, I think that is kind of useless. And then since those two angles have the same measure, we know that they're congruent, because that's the definition of congruent angles. Okay? All right, so you're going to have lots of little worksheets and quizzes that look like this right here, where I'm giving you a picture, I'm going to give you a statement and a conclusion, and you're going to tell me the reason why. So it's either going to be a property or a postulate or a theorem or a definition. So we're just going to go through this. Angle GXE. Okay, so GXE. So this angle here is a right angle. So if we know that that's a right angle, why do we know that the measure of angle GXE is 90 degrees? Because that's the definition of a right angle. Okay, get rid of this. All right, so you're given the figure. Why does the measure of angle BXD, so this angle added to the measure of angle CXD. Oh wait, I said that wrong. BXC. It's like this isn't working. BXC added to CXD equals the measure of angle BXD. Well, that's because of the angle addition postulate. Okay. Oops. All right, given this figure, angle DXE, why is it congruent to angle DXE? Well, that's the reflexive property of congruence. Anything's congruent to itself. All right, X, if they tell you X is the midpoint of segment AE, why do we know that X to E is half as long as A to E? We proved that yesterday. That's the midpoint theorem. All right, same thing. Look at the figure. CX, where's that? Okay, so this segment length added to this segment length makes this segment length. That's the segment addition postulate. Right. Look at the figure again. Angle EXF. Okay, so this angle BXE. So this angle, why do those two measures add up to 180 degrees? Because that's the linear pair postulate. Okay. Is that a ray? It looks, I can't tell if it's a ray or a segment. Kind of printed off weird. Whichever. If that bisects angle D, so XE, so this bisects angle D. Oh wait, if I tell you that bisects angle DXF, okay, so which that means this is congruent to this. The reason we know that's true is because that's the definition of an angle bisector. Whew. It's going to be a long day today. The brain is not braining. I feel so bad. All right, let's see what this next one is. Bx. Okay, so if that equals this, then that's congruent to that. That's the definition of congruent segments. Okay. All right. AX equals XD. AX equals XD. And CX equals XG. So, all right. So if we know that, so here's, oops, I'm going to do a highlighter. Here's what we're starting with. AX equals XE. You know that CX and XG are the same amount, and we add them to both sides. So that's just the addition property of equality. Because you know it was to be equal. If my, this printed, it updated to a different form of word. So like, some of my stuff doesn't look right. That's not supposed to be on two different lines. In my old one it wasn't, but apparently when it updated, it didn't fit it in there. Okay, let's see what's going on. So we know that the measure of angle BXC equals the measure of angle CXD, and the measure of angle CXD is equal to the measure of DXC. Then why does the measure of BXC equal the measure of angle DXC? That's the transitive property. Now, if you put substitution, that would be okay. But if these had been congruency statements, you'd have to put transitive property because you can't substitute shapes. You can substitute numbers. So if I say that angle CXE and GXE are right angles, why can we say they're congruent? Because we just proved that. Because all right angles are congruent. Well, that's a theorem. And then, given the figure, why do we know that angle BXC, okay, so this angle and angle GXF, why do we know that those are congruent? Because vertical angles are congruent. Okay. All right, let's see, next task. Let's see, complete the following proofs. So we've got the BD bisects angle CBE. So BD bisects angle CBE, which means those are congruent. Like anytime they tell you something, mark the diagram up with what you know from that. So it's like, okay, I know this because it was given. And then I knew angle CBD was congruent to angle DBE because that's the definition of an angle bisector. An angle bisector creates those two congruent angles. All right? If those angles are congruent, their measures are the same because that's the definition of congruent angles. Remember, we're trying to get to here, so we're having to get the measures. That's why that came in. The measure of angles CBD and ABC, so those two. Why is it 180 degrees? Because it's a linear pair postulate. And then, so why does the measure of angle DBE added the measure of angle ABC equal 180 degrees? Because right here, we knew that these were the same amount. So where that angle CBD was, we just plugged in angle DBE. So that was just a substitution. Okay. All right, next up, how many more pages is this? 2 more? That's not too bad. It's already 6:40. I'm hoping I get done with this before 7. All right, so B is the midpoint of AC, which means these two pieces are congruent. Okay, so that was one of my givens. That made that congruent to that. So that was the definition of a midpoint. And then C was the midpoint of BD, which made that for the same reason, definition of a midpoint. Now, this one, personally, I like to put everything on a different line. So this is one of the worksheets one of my colleagues made up. So they like to put everything, like if it's the same reason, they put it all on one line. I like to spread mine out, but you can do either way. It's not like, it's just personal preference. All right, and if we know these segments are congruent, we know their lengths are the same. If we know these segments are congruent, we know these lengths are the same, because that's the definition of congruent segments. And then why do we know that AB and CD are the same thing? Because BC is CD, so we can plug that in right there. So I would personally say it's a substitution, because that's how I think about it. If you put the transitive property, it would also be correct. Okay. All right, well, we got two more. That's not too bad. Okay. So last two, angle BXC is a right angle. Okay. So that was our given. That means that measures 90 degrees, because that's the definition of a right angle. Why do we know angle AXC's measure added to CXD's measures 180 degrees? Because that's the linear pair postulate. Then we could go, let's see, measuring AXC. So this one, let's do a different color. Measure angle AXC is the measure of angle AXB. So this one right here and BXC. Okay, that's an angle addition postulate. So what do we want to do now? Measure AXC, AXB, BXC. So they're doing AXB plus BXC. Okay, so there's that. Oh, so they put this where AXC was, and then they kept the measure of CXD equal 180 degrees, so that's a substitution. Okay, then where the measure of angle BXC is, they replace that with 90 degrees right there, so that's another substitution. And then we're going to subtract 90 degrees off each side, and that's going to leave us with the measure of angle AXB plus the measure of angle CXD is 90 degrees. So that's the subtraction property of equality. All right, and then last one, angle 1 is a right angle, and we've got to prove that angle 2 is a right angle. Okay, so that's given. Measure of angle 1 is 90 degrees, so that's the definition of a right angle. Angle 1, angle 2, those measures add up to 180 degrees because that's the linear pair postulate. Then where the measure of angle 1 is, we can plug in 90 degrees. That's a substitution. Then we can subtract 90 degrees off both sides, which will leave us the measure of angle 2 is 90 degrees, so that's a subtraction property of equality. And because the measure of angle 2 is 90 degrees, that makes it a right angle because that's the definition of a right angle. There we go. Oh, let me say this set of notes, I have a thing that lists what the homework is, but I don't have that on this thing. So, who knows what I was doing. Anyway, that gets those notes done. And then we're going to have some work to go with it.